Hi, I'm Civil Defense Engineer, and today I'm going to show you how to build a simple radio repeater. A radio repeater, all it does is it takes radio waves it receives and retransmits them, usually at a higher power and higher elevation, to really extend your range, to kind of get around that line of sight limitation most two-way radios have. Now, from our perspective, there are two motivations for building this. We want to extend our range, yes, that's the main objective. But the other thing is actually, if you remember from our radio communications for small teams course, one of the big things is TRANSEC. And when you're trying to transmit on high power to make your connection, you become a target because people with radio direction finding capabilities can really zero in on your position. So being able to take a radio repeater and hide it somewhere else away from you can obfuscate your position and really enhance your battlefield tactics. The other thing I wanted to say before we get into it is this doesn't have to be an expensive thing. When I got back into amateur radio after taking my test, I asked one of the gurus there about what it would take to build a repeater, and he was basically saying, oh, there's enough repeaters around here, and if you don't have $10,000 to get all the amplifier and all the equipment, forget about it. Well, I'm here to tell you that you can build a decent operational repeater for, well, basically 20 bucks, plus, any radios you have laying around. So let's talk about how this duplex radio repeater works. There are two main types of repeaters. A duplex repeater, which is the most common, receives on one frequency and retransmits on the other. So you need two radios, one for receive, one for transmit, and they're set to slightly different frequencies, or maybe majorly different frequencies depending on what you're doing. We'll talk about that later. Then you have the user's radio, which would be set up to be listening on the transmitter's frequency and transmitting on the receive radio's frequency, if that makes sense. So everyone that's hooked into the transmitter is listening on what frequency this is transmitting on and transmitting on what the repeater is listening on. Then you take your repeater and place it at a high elevation and then maybe have an amplifier. I'm not using that in this case, but we can perhaps use a higher power radio for the transmit run, and that will boost your range a little bit. But we're starting with simple here, starting with basics here. Because the power, that helps, but the main benefit is being able to get around that line of sight restriction of the simplex radio. So this is the most common type of repeater and one I'll be showcasing today. But the version I'm making is called a lunchbox repeater.
A lunchbox?
It certainly is.
What sort of lunch is in that lunchbox?
Well, let's see here. Oh, summer squash.
Because it fits in kind of a lunchbox looking thing. And the other type of repeater is a simplex repeater, and this operates slightly differently. It records your transmission and then listening for either a pause or the Roger beep at the end, and then retransmits on the same frequency. Now you can imagine that would kind of cause a real-time conversation to be a little bit tricky, because not only do you have to wait for the repeater to finish retransmitting your message, but then you also have to wait for the reply and then the retransmitted reply before you're ready to talk again. So it's kind of like, you're on the moon or Mars or something and you've got that time delay. And although that does limit your real-time conversation, it may have some benefits. I won't say it's just completely insane. I think it's theoretically possible to daisy chain them to really extend your range indefinitely. But I haven't actually seen that done in practice, so I might be just talking out of my hat. Now, if you spend a few $100s, you can actually buy a lunchbox repeater outright, and it's pretty much all ready to go for you, except maybe some programming. But we're engineers on this channel, and it's more fun to do it yourself. So if you put a dollar value on your time, it might be worth it to avoid the headache if radio stuff just isn't your jam. But if you watch this video, I'll do my best to demystify everything for you.
Big job. Take 2-3 days. Oh, this will run into money.
I say, how much?
Do the job for hourly rate plus cover materials plus overtime plus 10%.
Okay, once you have your 2 radios, the first item that you'll need, which is the secret sauce that makes the whole shebang work, is the duplexer. And this is just an Anytone RC108. It's called a walkie-talkie two-way relay box made in China. China! So yeah, as you can see, this is the finest Chinese knockoff, trying to be Anytone. It really shames me to say, but this is what you got to get. You know, I do feel like if China ever invaded the U.S., we'll be fighting them with materials that were made in China, and that's the way it is. But until we can get manufacturing going in the U.S., everything here is going to be some El Cheapo Chinese stuff. But it works, so...
China. You want to buy from China? That's great. Buy from China. Buy toys from China. China in particular. China. I have people that I know in China. China.
This cost 18 bucks off of either Amazon or Walmart even. And how it works is you've got your receive radio that plugs right into the microphone and earpiece slots on your receive radio. Boop. And then on your transmit radio. And that's all it is. So all it does is it takes the audio signals, outputs it from that one, inputs into the microphone jack on this one, and then using some baofeng programming tells it to key up, basically, and then it will transmit. Now, this is the basic workings of a repeater, but we can add on to this, build it out some more until we have our final form here. Probably the next modification I would make, and we're just talking hardware here for the moment, we'll talk about programming in a second, is maybe get some higher gain antennae, not just relying on these rubber duck antennae. That's probably one of the most bang for your buck modifications you can make. Next, these repeaters may be sitting out for a while, so you'll want extended batteries. But get the ones that have the USB jack in them, because then we can have extended batteries. So get a battery backup like this one. This is from Pocket Juice. Now, none of this stuff is sponsored, guys. I don't take sponsors. I just buy cheap stuff, okay? That works. And you can either follow in my footsteps or get some other stuff that works for you. But for this, I would say try and get one that automatically starts charging as soon as you plug something in. Don't get one that you have to like turn on, because that way when it starts running low, it will just start charging it. So then you can have this plugged directly into the USB charging ports on the bottom. So now we've got a great bare bones working repeater. We'll want to jerry-rig the box for it. And for that, these antennas will not fit in there. So we'll need to get some little pigtail connectors with the SMA that will connect to the antenna ports, and a little length of coax that we can route outside the box and then mount the antennae to the outside. So I'll go ahead and do that. You can do it in multiple ways. You can get a little Apache or Pelican box, or you can get an ammo can like this launch controller I made for my nephews recently. That works just as well. And that way you can just leave your lunchbox repeater out in the wilds for a long time, and it's sitting there ready to receive. Time for a build montage. I like to fit everything in a spot carved out from those foam cubes you can pull out. So there's a slot for the battery charger and the duplexer, then connect the radios to their USB ports, and to be honest, the cable management was a little tricky in this small little box. I probably should have gone with the next size up at Harbor Freight, but I fit in the radios side by side so their antennae are exiting in opposite directions. Then I had to cut a 3/8 inch hole for the coax to come out, which then makes it no longer water resistant, so then you've got to insert little rubber pass-through grommets. If anybody knows of a better solution for this, just let me know in the comments. I wouldn't throw this into the creek or anything, but should handle some light rain at least. All right, let's take a look at the radio settings for each of the radios involved. There are 2 radios that make up the repeater, and then we'll look at the user radio that connects to it. So there are 3 numbers that define your repeater, and those are the base frequency, the offset, and the PL tone. The base frequency is the repeater's transmit frequency, and also the frequency you'll be listening on. The frequency offset is the difference between the transmit frequency and the receive frequency on the repeater. Usually it's 5 megahertz for a 70 centimeter band and 0.6 megahertz for the 2 meter band, though you can pick anything you want as long as it's transmitting on something you have privileges for, unless we don't care. You can also do a split band repeater where the repeater is listening on, say, 70 centimeters and transmitting on 2 meters or vice versa. And that can really help your TRANSEC since, if you're monitoring on a waterfall chart, you're not necessarily going to see the offset light up right next to the base frequency. So it can make it a little trickier for someone trying to find your repeater. So finally, the PL tone is kind of an optional feature, but definitely a good idea if you live in an area with a lot of comms traffic. It's just a kind of a subaudible tone that is transmitted with the carrier wave to tell the repeater to retransmit, and then it'll ignore all signals that don't have that tone. So let's pretend this is the transmit radio for now. The transmit radio on the repeater. So the base frequency that I've selected for this is 430 megahertz, and I've already set it here. You just type it in, 430. Then, since this is the transmit radio, we want it at the highest power to boost our range or even be a decoy for our position. So make sure you go to, that's menu item 2. We want to set this at high power. Then go to menu item 13. And this is the transmit tone. And we may want to have something here, but I'm not sure why you would want this. It's not real ComSec, but if there are a lot of handhelds operating in your area, it may keep them from automatically playing when set to your repeater's frequency, unless they have this tone. You'd still see the signal on the waterfall chart, or any HTs will still play if they're not programmed to ignore these certain tones. So if you want it, you can add it. I think I'm going to leave it off, but you just pick a tone from here. Then go to menu 25. Make sure that this is set to off because that's the offset that we're going to use for the user radio. The offset is handled by the fact that you have 2 separate radios in the repeater. Then go to menu 27. And if you want to save it as a memory channel, you can do that. I'm not going to do that here because I've got a load in here already. All right, that's the transmit radio. Now we have the receive radio. Now we're going to pretend it's the receive radio. So this frequency is going to be your base frequency plus your offset, or minus your offset as the case may be. In my case, I'm using a +5 megahertz offset. So I will set my radio at 435 megahertz. So go to menu 0 and set your squelch. You may not want the repeater to be retransmitting weak signals, but I want it to be as sensitive as possible, so I'll lower it down a bit. Next, go to menu 11, and this is your PL tone for the receiver. So I'm going to choose 88.5. Then you can go to menu 27 and optionally save it in a memory channel if you want. Last thing for the receive radio, make sure the volume is all the way up or just a little bit off from all the way up. If it's too quiet, the retransmitted signal will likewise be quiet. That's it for the receive radio. Now we have the user radio, and things get a little more complicated for the user radio because it has to contain the info for both the repeater radios in one radio. So the first thing to do is enter the base frequency, which I forgot to do until the end. Otherwise, the offset will go up to 440 megahertz. Go to menu 25, and this sets the offset direction. You saw that it was positive before. You could have positive, off, or negative. So I've got a +5 offset. Then go to menu 26, and there I've got my offset already entered in there. Then go to menu 13, and this is going to have to match what the RCTCS was that we entered in last time. And so, yeah, it's got to be 88.5, just match that. The next setting I want to enter is menu item 2, and for the user radio, I want that to be low to keep as weak of a signal for TRANSEC purposes as possible. And then you can go to menu 27 and save it as a memory channel. All this is easier to do in the Chirp software. So if you're the comms guy for your militia or preparedness group, I would recommend you get acquainted with the software and keep a configuration management system so you know who is using what version of your load. So you can have local repeaters, let's look it up from repeater book, and then as well as all your own private repeaters programmed into every team member's channel. And don't forget to input the base frequency here of 430 megahertz. Now when I key up, you'll see that it jumps up by 5 megahertz. Whoop. And then when I let go, you hear that static? For a split second, that's the repeater still transmitting. So that's how we know that we've successfully hooked into it. Now we can turn on another radio that's also hooked into it. And it's got lots of static, so it's working! It's working! So that's how you can build a simple baofeng repeater for just a few dollars, or a few more if you want to build it out like this one. But all you need are a couple of baofengs, that little duplexer, and if you want to just stick that in a backpack, there you go. That's all you need to get started. And you can really increase your capabilities by doing that. Extend your range. Now, honestly, in initial testing, I got maybe 3 miles out and then I couldn't connect to it anymore. But that's because on the UHF band, with all the trees around here, it's very easy to get attenuated. You really need to get just above that, and that will really help you. So if you've got a tall building or a tower or something, or a very tall tree that you can get it up to the very tippy top of, that's the best. And theoretically, you should be able to get maybe 20, 30 miles but at least 10. Now there are other cheaper baofengs that have higher power, like the UV5RM or the UV25. I think those go up to, I think that's 25 watts. That's what the 25 stands for, right?
Wrong.
I'll fact check that. But that's still a pretty easy way to get your signal boosted a little bit out there. Now, I didn't build my little box big enough to house this one, so, but this one could probably really boost my range as well, but not as much as having a high gain antenna that's placed way up high. That's the most important step, especially since even with the repeater, you still want to pay attention to TRANSEC, still only use the minimum amount of power to get your transmission through to your listening party. So that's all I had for you today. This is Charlie Delta Echo, and I do militia stuff, I do radio stuff, I do gun stuff, I do engineering stuff, all about citizen defense. So if that sounds interesting to you, think it over, maybe subscribe.
If you think it over, let me know. You got my card, I got the book, you know.
Oh.